Hello, welcome to Math 1324. This is Chapter 10, Section 2, Example 5. And in this example, we want to graph the parabola and give its vertex, axis of symmetry, x-intercept or intercepts, and the y-intercept. Okay, so here's the thing. For this, we've got really five different questions. And the 5 different questions are A, graph the parabola. B, find its vertex. C, find the axis of symmetry. D, find any x-intercepts. And E, find the y-intercept. And here's the thing. With parabolas, there are a few things we need to know. First of all, the domain is all real numbers. But if we have y equals a times f of b times x minus h squared, well, let's do it this way. I'm going to go ahead and show you the vertex form. So for the vertex form, here's what we have. We have y equals a parentheses b parentheses x minus h close parentheses squared plus k. Now this should be very familiar to you. It's pretty much the same transformations that you saw. A is a vertical a vertical stretch. B is a horizontal stretch. H is a horizontal shift. K is a vertical shift. And A can be negative or positive, and B technically can be negative or positive, but we don't usually deal with those. Okay, so here's the thing. The range, if you have this form, if A is positive, that means that you will have k to infinity, because positive means that the parabola is opening up. Now, the vertex is actually the coordinate h comma k, and I'll talk more about that in a second. The range, but if a is negative, is going to be negative infinity to k, including k. The reason why is because for this parabola, it's opening down. And again, the coordinate for the vertex is h comma k. So this is for a being positive, this is for a being negative. So if a is positive, it's opening up and the vertex is a minimum. If a is negative, it's opening down and the vertex is a maximum. And that affects as to whether the range is k to infinity or negative infinity to k. Awesome. Here's the thing. If I have the general form, and I want to put it into the vertex form here, I have to do something. The h value is actually negative b over 2a. The k value is just whatever the f of whatever h is. In other words, get this value, then plug it in for the x's, and you'll get your y value. That's really all it is. And once you have that, you'll get this form. Generally speaking, let's just get rid of all that. We specifically have it like that. There we go, better. A times x minus h squared plus k. There is no b in the vertex form. For the general form, there is one. Awesome. Now that we know all this, to graph the parabola, first, you could just type that into the calculator and see what you get. I'm not going to do that. I will say on A, graph on the calculator. Go ahead and have fun with that. I'm not going to deal with that. What I want to do is I want to go ahead and find the vertex, the axis of symmetry, the x-intercept or intercepts, and the y-intercept. Now, starting with the vertex. For the vertex, we need to find h and k. H is the x-coordinate of the vertex, which is negative b over 2a. Now, in this case, a is the number in front of x squared, b is the number in front of x, and c is always the plus or minus at the end. If there isn't anything at the end, it's 0. And if there is no x term, b is 0. So just be aware of that. Okay, so h is negative b. Now, negative b just means the opposite of b. B in this case is 7. C is 12. A is the number in front of x squared. It's understood to be 1 this time. So that means that h is negative 7, the opposite of whatever b is, all over 2 times 1. Negative 7 over 2, just keep it as negative 7 halves. And once you have that, plug it in. The k value is going to be, parentheses, negative 7 halves, close parentheses, squared, plus parentheses, negative 7 halves, plus 12. And at this point, just simplify. You can just type this in on the calculator, exactly the way it looks, and it will tell you the fraction. In case you don't have your calculator on you for some reason, it will look something like this. Let's make this over 4. So minus 14 over 4 and plus 48 over 4. And the reason I'm making all of these over 4 is because 7 squared is 49, 2 squared is 4. And so the LCD between all these should be 4. So I'm going to go ahead and make that happen immediately. So 49 minus 14 is 35. 35 plus 48 is 73. So that should give you 73 over 4. Yeah, that's not. That can't be simplified. Good. Now, just for confirmation, I'm going to go ahead and type that into the calculator because that's kind of a weird number. So negative 7 over 2 squared plus negative 7 over 2 plus 12. $83 over 4. I can't do basic math. Awesome. Okay, so once we have the h and the k, the vertex is simply those two in coordinate form. And that's it. Good. Now, as for the axis of symmetry, for every parabola, there is an axis of symmetry, and it is a vertical line that goes through the vertex. So once you have your vertex, the axis of symmetry is the equation negative 7 halves. X equals negative 7 halves. And it has to be x equals negative 7 halves. It's very important. Without the x equals, it's wrong, because it's the equation of a vertical line. Next, we want to find the x-intercepts, if they exist. So to find the x-intercepts, we set the function equal to 0. In this case, x squared plus 7x plus 12 equals 0. Now, first of all, assuming that there are x-intercepts, if there are not, then you get imaginary numbers. If there are x-intercepts, you can solve this in one of two different ways, really. First, I'm going to factor. The factorization is x plus 3, x plus 4, and set it all equal 0, then set each one of those factors equal 0. I will be linking in Blackboard to a video on how to factor. It's a very basic and simple form of factoring, but it works. So I get both x equals negative 3 and x equals negative 4. In my math lab, I believe that they want this. I think that's what the answer will look like. For me, if I was doing this on my own, it would be negative 3, 0, negative 4, 0 in coordinate form. Now, that's just one way of factoring this, or excuse me, of solving this. Another way is to use the quadratic formula, and the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And if you know the quadratic formula song, it's a lot easier. You know, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Yes, Pop Goes the Weasel. I mean, and yes, I should be on, what is it, American Idol? Yeah, I mean, just the best voice ever. Anyway, A is 1, B is 7, C is 12. Plug them in, top them in exactly, and that will tell you negative 3 and 4. Now, you can only do one or the other at first, so either a positive or a negative. But there is a way of doing this on the calculator, but it requires a program. And I will go ahead and show you that right now. Actually, what's the last one? The y-intercept. Yeah, let's go ahead and do the y-intercept real quick. So for the y-intercept, that's just where x equals 0. And if you plug in 0 for all these, you just get 12 left over. So that means that y equals 12 is the y-intercept. I believe it just wants it in y equals form. For me, I would say the coordinate would be 0, 12. But I believe my math lab wants y equals 12. Alrighty. Well, I will see you in the calculator. Have fun. Okay, so welcome to the calculator. And I have already put in a program here. So if I click on program, you've got quad here. So if you go to edit, you can kind of see what it looks like. So prompt A, B, C, A, B, and C being the A, B, and C that we talked about in the question. A here is 1, B here is 7, C here is 12. Now, all I did here is I did the quadratic formula. So quadratic formula, and this is with the positive, so I made that the y value. And then the quadratic formula with the negative makes that the x value. And then just display what the roots are, x and y. And that's pretty much it. It's a very, very simple program. Now, if it gives you an error, that means that your quadratic formula, or your quadratic equation has no real roots, is what we call it. And so that means that your graph will never cross the x-axis. Anyway, it should work otherwise. So here, if I go to program, and on execute here, I want to execute the quadratic formula. So I click on 2 for the second one that I have on there. It says program quad, click enter. So A is asking us what's A in here. Well, we determined A was 1, enter. What's B? Well, B is 7, enter. And C is 12, enter. Now notice it says roots equal, and then negative 4 and negative 3. Done. So this is your first x-intercept. This is your second x-intercept. In other words, it's where the quadratic, where that quadratic function is equal to 0. Now, this I found from just a program. Oh, sorry. Well, it's kind of hard to see all the way. Anyway, I will go ahead and link this page to Blackboard here. And you will be able to see where I got this. It's just from CSUSM. I'm not really sure who that is, but that's where I got it from. It works perfectly fine. It's a very simple program. I'm going to go ahead and put this program into Blackboard for you so you don't have to type it in. But if you want to kind of practice typing in a program to the calculator, go ahead and try it. It's actually pretty interesting, especially if any of you decide to become programmers. Alrighty, well, that's pretty much it. Let me go ahead and go in here. Let's go ahead and graph this. So if we were to graph x squared plus 7x plus 12, press graph, and there you go. Notice that the vertex is just right here below. Oops. Zoom out just a little bit. Let me go here. Let's change the window to -5 to 0. How about that? and then -5 to 5. That helps us zoom in. So the vertex is right there, and you can see how it's just below the x-axis. So it crosses in 2 different places there. Alrighty, well there you go. I'll see you in the next video. Have fun.